Well, welcome everybody to this week's Inequality and Social Policy Seminar. I'm Chris Winship. I'm a professor in sociology and also the senior faculty at the Kennedy School. This series is made possible by the James N. and Kathleen D. Stone PhD Scholars Program and the Malcolm Wegener Center for Social Policy at the Kennedy School. Today, we are delighted to welcome Professor Laura Nelson from Northeastern. She will be introduced by John Towie, a PhD candidate in sociology here at Harvard. So John, please take it over.
Great, thanks, Chris. Hi, everybody. My name is John. I'm in the sociology department, PhD student. So I am just absolutely thrilled to introduce Professor Laura K. Nelson to you, who will be presenting her work on leveraging machine learning to measure intersectionality. Professor Nelson is a scholar of social movements, culture, gender, institutions and organizations, computational methods, and focuses on automated text analysis, and is also an advocate of open source, open science, and reproducible research. Professor Nelson is an assistant professor of sociology at Northeastern, is on the core faculty at the NU Lab for Text, Maps, and Networks, and is affiliated with the Network Science Institute also. She's also on the executive committee of the Women's and Gender and Sexuality Studies program and on the editorial boards of Sociological Methods and Signs. I am personally very excited to welcome Professor Nelson. I was introduced to Professor Nelson's work on computational grounded theory as part of a course on text analysis a few years ago here at Harvard Sociology. This path-breaking approach bridges the divide between interpretive research and reproducible, rigorous quantitative work with very broad applicability to different kinds of text data. So I'm really excited to hear how machine learning can help us analyze intersectionality. Thank you for being here, Professor Nelson.
Thank you, Professor Winship, and thanks, John. So as Chris said, I'll keep an eye on the chat. So if there are any clarifying questions, short questions, I'm happy to answer them. So I'm going to start this with 3 proclamations, and these are 3 major themes that I hope you take away from the talk today. The first one is that interaction effects are not the same as intersectionality, and I will talk a bit about that. The second one is that machine learning is inductive. It is a fundamentally and mathematically inductive method, and that has implications for how we can and should use it in research, specifically social science research. And the third statement I want to make and hope that you come away with today is and perhaps the future of machine learning is qualitative. So that's probably a bit more controversial, and I'll talk about why I think that should be an important future of machine learning in the social sciences. All right, I'm going to lay some groundwork first. So I often give talks and I teach to interdisciplinary crowds, and I found very quickly that we can be using the same words and we mean something very different by these same words. So I just want to get a lot of definitions out there just so we're on the same page with everything. So the first definition I want to go through is intersectionality. It means a lot of different things to a lot of different groups. It's used across many different disciplines. By intersectionality, I mean it is a theoretical framework for understanding how social identities and categories combine with each other and also interact with systems of social, cultural, economic, and political power to create distinct and unequal lived experiences. So all parts of those are important. It's about how social identities combine with each other and with systems of political power and cultural and social power to create these unequal lived experience. So that's what I mean by intersectionality. I'm talking about it as a research paradigm that includes 5 points here. So identities and institutions are relational. Identity is an embedded experience. So I will experience my identity differently depending on what institution I'm embedded in. Nested hierarchies are situationally specific. So no one institution or identity is always the dominant one. It depends on the situation. And related to that, context is key to knowing. We can only know those nested hierarchy within the context that we're studying. And categories are mutually constitutive. And this gets to the additive, the interaction effects. So when 2 categories intersect, each category is changed. They're not just additive, they change each other as they intersect. So those are the kind of 5 main principles of intersectionality as I am using it. I'm also going to talk about deductive and inductive analysis. I use this in the social science sense, not so much the computer science sense. So deductive analysis, you start with a theory, you analyze data, and you see if your hypotheses are supported or not through your analysis. The inductive method kind of takes the reverse. You gather data, you look for patterns in your data, and you develop theory out of those patterns. So deductive versus inductive. And I'm going to talk a little bit about inferential statistics and machine learning. So inferential statistics in its most traditional form, you assume a known relationship. So you say there's a quadratic relationship between education and income, because PhDs don't make anything. So there's a quadratic relationship, and then you gather data and you see if that relationship actually fits the data. In that sense, it's a mathematical relationship. You're assuming a theoretically mathematical relationship. It's very rigid in some sense. But what's great about it is you can assess statistical significance with that all-important p-value to know if your findings are significant, and the parameters are very interpretable. So you know the exact relationship between education and income through that beta coefficient. So it's a really nice way, very simple way to represent the social world. Of course, as soon as it became dominant in the social sciences, particularly sociology, it was critiqued. This kind of view from nowhere, if you think of Dorothy Smith's view from nowhere. And so a lot of people critique this, everybody from C. Wright Mills, who was critiquing the strong empiricism, Andy Abbott, his "we don't live in a generalized linear reality," feminist theorists, critical race theorists, all kind of claimed when you flatten out the world in the way that is necessary to do inferential statistics, you aren't really fully understanding the social world. So this is not a social justice claim. This is, if you want to understand the social world, you truly want to understand what's going on and cause and effect and all of that, you cannot flatten it out in this way. There is no view from nowhere in the way that traditional inferential statistics would want to claim. And I just want to go through a few of the specific critiques, specifically from feminist, critical race, intersectional scholars. So one of these is intra-categorical complexity. There are many people in the social world that don't fit our standard categories, race, gender, class, and they tend to get dropped from the analysis, or we don't include them, or we don't recognize them as existing. So the things that don't fit in the way we think they should don't get included in the analysis. The other is intra-categorical complexity. So all of us are made up of multiple intersecting identities that can become more or less important in different situations. So when you're trying to put them into these kind of binary or categorical variables, you lose that intersecting categories within each person that we're trying to study. The other is anti-categorical complexity. So this specimen here is the Emerald Elysium. It is part plant, part animal, has a brain, it moves around, but it also uses photosynthesis. So there are potentially social categories that we've never thought of before, that we can't posit before we actually dig into data, that get completely missed when we try to put people into these slots. And that is, these categories might be really important to understanding the social world. So anti-categorical complexity is this idea that we potentially don't know all of the categories that might be really important to a social situation we're trying to study. And the last isn't really about categories, it's about what processes, what social processes we're studying when we slot people into this inferential statistics paradigm. Because traditionally, we weren't looking at the everyday interactions, everyday processes that a lot of scholars, particularly feminist and critical race scholars, these are the processes that replicate inequality. This is how inequality is sustained over time. It's through interactions, everyday processes. And that's what we really need to be studying if we want to understand the perpetuation of inequality over time. So feminist scholars in particular use things like institutional ethnography to think about these everyday interactions and get at these everyday interactions and processes that they found is so important to understanding inequality in the social world. So to this kind of world, so we have the inferential statistics paradigm that is very dominant in the social sciences. A lot of people are critiquing it because it doesn't actually cover the social world and help us understand it in the ways we might want to. Recently, machine learning has become a very growing and important paradigm and research paradigm in the social sciences. So machine learning, in the way I use it, is the algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, relying on patterns and inference instead. This is a really important definition. So sometimes we conflate computational statistics with machine learning, So I do want to distinguish between machine learning and computational statistics. So this is what I mean by machine learning. And what's really, really exciting for me, and for, I'm hoping for a lot of scholars who have been critical of the inferential statistics paradigm, is that machine learning, and with it kind of the associated data that was important to allowing machine learning to grow, addresses most of the concerns that people had with this statistics paradigm. So we have more data. We can get data on the people who don't fit the standard social categories that we typically had to drop, or we just couldn't get data on. We have very high dimensional data, so we can have thousands or even millions of dimensions on each unit of analysis, person, nation, whatever you're studying. And that can capture this multiple identities or multiple intersecting identities within our units of analysis. We can, of course, use unsupervised machine learning to identify categories that we may not have thought of before when we were coming into an analysis. So unsupervised methods can allow categories to emerge from the data. And yes, you can do some inductive stuff with inferential statistics. I'll get to that a little bit, but machine learning allows us to do that at a much larger scale. And the type of data we have access to is often exactly the interpersonals and everyday kind of processes that a lot of scholars thought were so important to understanding inequality. So we're not just getting things like education, income, work, etc. We're getting these interactions over social media. People are sharing everything they do every day. That's the type of data we have access to. So we have a lens into these everyday processes that were so exciting for feminist scholars when they were doing work in the 80s and 90s. So it's a potentially very exciting moment for sociology, for people who are critical of the kind of standard inferential paradigm here. So what's going on in social sciences as we're trying to merge our standard methods that we've spent a lot of times developing with the new paradigm of machine learning. And what's happening is we're trying to merge it into we as in the machine learning community, the people who are using these methods, are often trying to merge it into the inferential statistical paradigm. And they're finding that it doesn't fit. They don't know how to fit these two paradigms together. So machine learning, unlike inferential statistics, it assumes unknown relationships, right? It's learning patterns from the data, and you fit the data and say, what are the patterns in the data? And that way it's empirical rather than mathematical, and it's elastic. You give it more data, it's gonna find new patterns. The last two things are important and troubling for people who do statistics. So there's no real statistical significance measures here. You tend to measure the benefit of your model if it generalizes to other data sets. So you train it on one data set, and if it generalizes to many more, it's a good model. The parameters are really uninterpretable. They're really black box, or they're just used for prediction. And these two things are really, the inferential statistics people really struggle to figure out, what do we do with this? How do we think about statistical significance? How do we think about these parameters that are output with machine learning models? And that's caused a lot of people to kind of pause and think about, how can we integrate these two frameworks? And one of the fundamental mismatches, or I don't know, dissonance between these two frameworks is that I claim inferential statistics is a fundamentally deductive method. If we're thinking about specifically the traditional way of using it, you posit a relationship, you see if your data fits the relationship. Whereas machine learning is a fundamentally inductive method. And by fundamentally, I mean mathematically. The assumptions behind machine learning are fundamentally inductive. And I really do mean all machine learning. Supervised machine learning and unsupervised machine learning is a fundamentally inductive method. And so trying to kind of merge these together has led to these questions and dissonance that has caused issues with scholars who are trying to do it. So I want to take a step back in this talk and invite us all to think about the possibility that machine learning and other computational methods, we should not be thinking of them as a quantitative method with an inferential statistics epistemology, or not trying to force them into that epistemology. We can be more productive with these methods if we think about them as a quantitative method with a qualitative epistemology. So that's what I want to invite us all to think about in the talk today. And I'm thinking in particular of Matt Zalganik's recent work on the Fragile Families Challenge, where he invited scholars to try and predict life outcomes based on early data. So the Fragile Families data is a huge data set of early childhood variables. And he invited scholars to try to predict later life outcomes from those. And through this, hundreds of teams submitted the most sophisticated prediction, deep learning algorithms to predict these life outcomes. And they found that logistic regression was the best. None of the most sophisticated machine learning algorithms, not really, didn't outperform simple logistic regression. And he was surprised by this, Matt Zelganic, and others were surprised as well, and really started to think, what are we doing with machine learning? Like, if it's not going to lead to better prediction, what are we doing with it? And so I want to invite everyone and say, what if we don't try to just replicate what we've always been doing, but let's bring in qualitative methods and see if we can leverage machine learning in a different way. And that will really make that paradigm much more powerful as we apply it to social data. And I'm going to show you one way that I've done this using the 19th century US South as a case study and thinking about how we can use machine learning specifically to think about intersectionality and intersectional experiences in the US South. So this picture is a little unfair because it's neither the 19th century nor the US South. This was taken in 1913, I believe, in Chicago, but it illustrates a general principle about the long 19th century, which it was incredibly inherently intersectional. Black women did not experience this century the same way that white women did, certainly, and did not experience it the same way that Black men did. So it's like intersectionality really heightened in this period because of slavery, racist oppression, Reconstruction, and all of that. So it's a nice century to think about what was happening and how were different identities experiencing this century in a different way. And of course, we know a lot about this. A lot of historians have really dug into the archives and theorized and had a lot of evidence about how women experienced, Black women in particular, experienced slavery different from Black men, how white women certainly experienced this period different from Black women, white women and Black women. And so we know a lot about this. So it's a great opportunity to leverage new sources of data and methods to think about how we can use these methods as a new lens on a subject that we know a lot about already. So I'm using data from a library at University of North Carolina called Documenting the American South. So it consists of personal narratives, ex-slave narratives that's really just describing largely from people who aren't typically in the scientific record. So women, laborers, soldiers, Black men and women. So they're just describing the way they experienced this century in these personal narratives. So it's the type of data that ethnographers and feminist scholars really want to get their hands on, which is these everyday interactions and processes that make up our lives. So it's a nice data set for that. I collected documents from ex-slaves narratives and these personal narratives, and it's 414 book length narratives. So they're very long. 41 of them were by white women, 89 by white men, 48 by Black women, and 243 by Black men or about Black persons. And I can talk about why I made that decision on that last one. That's kind of the breakdown of race here. And to analyze these data and to show the potential of machine learning methods to measure intersectionality in particular, I'm using a machine learning method called word embeddings. And I will just very briefly go over the intuition of word embedding models here. Some of you might have seen them already, but the intuition is that to understand how a word is used, you can look at how frequently it's used. So some of the social theorists in the room might recognize that the work on the left side, that's Marx and Engels' Communist Manifesto. On the right, it's Machiavelli's The Prince. So if you're thinking about the word working, Marx and Engels used the word working much more often. That's just a sample on the left of how often they used it than Machiavelli, but they also used it in a very different way. And we know that they used it in a different way because of the context in which it was used. And that's the intuition behind word embeddings. So word embeddings turn that word working into a vector, and the vector is a vector is just a series of numbers. And that's created by all of the other words that co-occurs with the word working across your entire corpus. So you have each word as a vector. All of the words constitute this vector space. So it's all kind of plotted in the same space. And the intuition is that words, vectors that are close together in this high dimensional space are going to be semantically similar to one another. So it's a relational way of looking at words and their relationship to every other word in a corpus. It works based on prediction. So you train a word embedding model on a corpus, and then you give it a phrase like the sociological imagination, and you give it the and imagination, and it tries to predict that interword sociological based on the way sociological is used in the entire corpus, or you can do the opposite. You can give it sociological and it tries to predict the surrounding words, the and imagination. So you train it on this large corpus, and then it creates kind of a prediction algorithm here for it. So this is a large word embedding models of Google Docs, Google Books done by Google employees. So this is one of the first large word embedding models, and you can read this as analogies. So sorry, I'm losing my voice here. So women are to sewing as men are to carpentry. Women are to nurse as men are to surgeon. So that's how you would read this word embedding model here. And computer scientists kind of panicked when they saw this output and said, oh my gosh, there's a lot of social biases in these word embedding models. That's not great because we want to use them in systems to perhaps recommend resumes. So we don't want biases to be forwarded along in these systems. Social scientists said, wait a minute, this is fantastic. So basically you're telling me that machine learning absorbs all the social biases that we have in our language, and we can see it laid out in front of us, all these kind of intersecting systems of cultural power. So it was a very exciting moment for social scientists and humanists to say, we can use these methods to lay bare kind of the cultural biases in the very language that we use, the inequalities in the very language that we use every day. And I want to push this one step further and say we can use these methods to reveal, when used on the proper data, to reveal the lived experience under intersecting systems of cultural power. And that's what I'm trying to do with this project here. So this is a lot, sorry, this is a wall of text here, but I attempted, and I think succeeded, hopefully, at measuring intersectionality using word embeddings. So I mapped 4 combined social identities, Black and white men and women, against or within 4 social institutions, the polity, the economy, culture, and the domestic, and that comes largely from classical social theory built around the transition from agrarian capitalism to industrial capitalism. And I used this method to produce 4 visualizations showing the specific and relational position of each identity embedded within social institutions as conveyed in the context of largely pro-abolitionist narratives from the 19th century US South. So this is trying to map on the methods directly to the epistemology of intersectionality. I didn't want to do it separately. I wanted to take seriously the epistemology of intersectionality and then use those methods to really embrace that method of knowing to see what we can do with this. So that's why it was kind of complex there. So to do so, I used vector addition and vector averaging. So one of the benefits of vectors is you can add them together and the added vectors create a resultant. So the way I did this was synonym pairs. So to create, for example, the Black women vector, I added all of the synonyms from the women column with the Black column pairwise. So women plus Black, women plus colored, women plus Negro, and then divided by the number of synonym pairs. So it's just an average way of creating vectors here. And this creates this large vector space where every vector is related to every other vector in this space, including the 4 created resultant vectors that I created. So Black women, white women, Black men, and white men. So these 4 social identities have a distance measured through cosine similarity, which is just an angular distance between 2 vectors, to every other word in the entire corpus. So for example, the cosine similarity between white women and dainty is 0.52, indicating those 2 vectors are more similar to each other than, for example, Black men and dainty, which have a cosine similarity of only 0.25. So that's what we get here across all of the words, is this similarity measure in this very high dimensional space. To identify the social institutions, polity, economy, culture, and the domestic, I took the 50 words that had the highest cosine similarity to each of these 4 social institutions. So it's a list of 50 words. And of course, the 4 social identities have a cosine similarity to each of these 50 words. You can average it out and you get an average. Again, a lot of averaging because word embeddings are very sensitive to context and word choice. So when you average, you can, it's more robust to kind of the sensitivity and word choice that you have going on in word embedding models. This is a principal component analysis of those 200 words, so the top 50 for each of these social institutions, just to give you a sense of kind of the discursive backdrop that's going on here. So you can see polity, culture, economy, and domestic words. And the way I interpret these two axes in this principal component analysis is the left side are aspirational words. So things like commonwealth, national, state, civilized, and also respectability, opulence, erudition. So these are not the immediate needs that a nation or a person needs, but they're aspirational needs. And on the right side, you have very practical things like earnings, dues, paying, dime, or milking, chores, ironing, babies, etc. And on the y-axis, you have the individual on the bottom, so milking and chores on the practical side, intellectual endowments on the aspirational side, and on the collective, you have the kind of national things. So national practical would be dues and earnings, national aspirational, commonwealth, national, state, civilized, etc. So that's just kind of the axes of discourse here. So the next visualization is very complex, but I wanted to have it to stick to the intersectionality here. There's a question here, how did you choose the dimensionality of the embeddings? Yeah, so I used vector lengths of 100, and I did some sensitivity checks on it, but that's an important question. Actually, I would love to address in the Q&A more is how do you do sensitivity analyses on these word embeddings? So I used a vector length of 100, but I think we should talk more about sensitivity analysis there, which is really important. So we have this discursive space, and then I wanted to embed the social identities within different aspects of this discursive space to show how when identities are embedded within different institutions, their relationship to one another changes. So I'm showing 4 scatter plots in the next one that shows these social identities embedded in these social institutions. So what you can see here is on the left side, the culture vector leads to a clustering of race. So the culture vector distinguished between white people and Black people. If you look on the right side, you see it clustered more by gender because the domestic vector clustered by gender. So white women and Black women were closer to the domestic vector compared to white men and Black men. I mean, then when you see the economy vector on the y-axis there on the lower one, you see this interesting intersectional effect where white men and Black women are actually almost equally distant to the economy vector. So what I'm just trying to show here is that when you look at identities relational through different institutions, you see kind of the clustering of the identities are changing. And that really is trying to capture the embedded nature of intersectionality and intersectional experiences here. This is the same data, the same information. This is the 95% confidence interval on the difference between cosine similarity means using the bootstrap method. So I created 40 random corpuses, same length as the main corpus, created the 95% confidence interval here. It's a lot of lines, but we can see that Black women and white women are significantly closer to the domestic vector compared to Black men and white men. We see white women and white men are significantly closer to the culture vector compared to Black women and Black men. And we see that Black women and Black men are closer to the economy vector compared to white women and white men. Sorry, so that's the same information as the previous chart, just showed more statistically. And we can see the actual magnitude of the difference plus the statistical significance of the difference. And this is one way to check your model, although as Bill was asking, the other ways, another thing you need to do is sensitivity checks, which I would love to talk more about. So I want to go back to the actual text and try and think about what do these differences mean in the actual text? How are these distances between culture and white men and white women displayed in the actual text? And it's a little tricky to go from word embedding models back to text because word embedding models don't look at documents. It's hard, you can't just identify documents that are representative, but I tried to pull out passages that exemplified some of the associations. And I'm going to start with the culture associations here. So many of the cultural words in this text, like gentility, refinement, intellect, were largely reserved for descriptions of white people in this corpus. And remember, this corpus is largely anti-racist and pro-abolitionist. So this is not just a random sample of text from the 19th century, which would be much more racist than this particular corpus. So even in this corpus, those culture words were largely reserved for white people. And we see this in a lot of different ways. So this is a white woman talking about her time in Washington during the Civil War when the Southerners were kicked out of Washington. And she said when that happened, all the refinement, all the white Southerners were kicked out of Washington, all the refinement, all the intellect, which once constituted the charm of Washington society, has departed with my brethren of the South. So there was this idea that white Southerners had refinement, intellect, gentility, that were the defining features of the white population in the South. This is a white man describing his wife: erudite without pedantry, charitable without parade, soft of speech but duly assertive, stickler for the social proprieties but void of prudery, ever genial but never frivolous. So this was kind of the way both men and women were described in these narratives. White men and women were described in these narratives. On the side of Black people, they very explicitly said at times that, look, we're not open to genteel society. The only way that they had access to genteel society was for house servants who were somewhat closer and can learn more about it. And these house servants were sometimes greatly envied, but it literally was not allowed to Black society in this time. And there was also very different cultural words were used to describe Black men and women. In this case, a Black man, he wasn't described using the words gentility, refinement, intellect. He was described using merit. They have taught him self-reliance and a desire for teamwork. They have taught him thrift. They have given lessons in integrity and high moral purpose. So very, very different words to describe Black men than we saw to describe white men and women in the South. And this is the intersectional effect here is interesting because these words are cultural words like thrift, self-reliance. So they pushed Black men a little bit closer to the cultural vector, but it was used in a very different way than was used to describe white men and women. And Black women weren't described using these terms either, these kind of cultural terms like self-reliance, the way that Black men were. So many, many layers of intersectionality here. And the other just kind of brief example I want to give is this proximity of Black and white people to the economy compared to Black and white men and white women. So of course, white women were attempted to be largely spared of the economy. They were relegated to the domestic. Black women could never escape the economy. They were always working, either forced to work in slavery or working after slavery and Reconstruction. So Black women were always proximate to the economy in the way that white women were not. And this comes through in the text a lot. So here's a quote describing a Black woman, an ex-slave. At the time of her death, she had acquired by her industry and care more than $400, the whole of which, after paying the expenses of her sickness and funeral, she left by will to charitable purposes. So this exalting Black women for their ability to make money is a strong theme throughout the text here. This is actually Sojourner Truth talking about how I thought I would work and put some money in a savings bank. And then she kind of reflected on this. My industry had doubtless kept some poor wretches from paying work. I felt it and I said, Lord, I will give all back that I have ever taken away. But this idea that being a self-supporting woman is a source of pride for Black women. The word industry was also used to describe white women, but it was always related to her ability to manage a household. So her industry, her management, her executive ability in caring for and carrying on her household affairs are still wonderful memories. So this is describing a white woman here. So yes, industry was used to describe white women, but always in relation to the domestic rather than her ability to make money and be a self-supporting woman. So very different relationship between Black women in the economy and white women in the economy. So that's what those word embedding associations that I was showing you, that's how they appear in the actual text and demonstrate how different identities had a very different experience of this time. And this is not all that surprising. Historians have uncovered this and talked a lot about these different intersectional experiences. So I wanted to do one last association with this just to show a slightly more complex relationship, and that is between race, gender, and authority. So one of the big fears of white society during this period was the fear of a slave rebellion. In many locations, the Black population outnumbered and outstrengthened the white population, and so this perpetual fear that they would start an uprising was always there. And one of the theories is that Black men were afforded a measure of authority over Black women in order to uphold gender schemas. It was a gender schema thing, but also to quell the potential for slave rebellions by giving them a little bit of authority. On the other hand, white women had real authority over both Black men and Black women. So there's this theory that white women actually had proximity to authority in a way that challenged gender identities because of the racial relations here. So I looked at authority, the authority vector, and the distance between the identities and the authority vector. And I found that it upheld gender schemas. So Black men and white men were significantly closer compared to Black women and white women. And interestingly, Black men were significantly closer compared to white women. So this is supporting the idea that Black men were given a bit of discursive authority in order to potentially quell rebellions or to uphold gender schemas, and white women and Black women and white men and Black men were equally distant to the authority vector from one another. So this is really upholding gender schema, not race, in the way that some people have theorized. So this is just a slightly more complex kind of discursive association and intersectional experiences in this period here. So to summarize the empirical part of this talk, the culture vector distinguished the races in a really deep and important way. Domestic words, unsurprisingly, distinguished by gender. The economy had an interesting intersectional dynamic, which we largely knew, but this is a new lens on thinking about that. And I found that authority, at least discursively, upheld traditional gender schemas, even though white women had real authority over Black men and women in this period. So these are the kind of substantive findings from this foray into thinking about intersectionality and 19th century US South. So this would potentially just be the beginning of analysis. You wouldn't necessarily stop here. You can go deeper with this, much deeper. Why didn't politics separate the races as I expected? Does the kind of economy relationship have anything to do with the Washington Du Bois debates of the early 20th century, which were deep debates there? How did authority present discursively? What are these implications? And importantly, for me, can we use these methods to do more direct comparisons across geographies, time, and context? So using this method as a more formal way to measure intersectionality, so you can do direct comparisons between geographies in the 19th century or compared to Britain and the Caribbean, or across time and context. So that's what's really exciting to me, is to use these methods to draw out these comparisons in an intersectional way. Context is always important. So in my last about 5-6 minutes here, I want to now take a step back and reflect on what this means methodologically. How do we think about the future of machine learning and the ways we can use it to study the social world? And I see this question about how results vary. So let's leave that to the discussion, because it's a really good question there. So what does this mean for the future of machine learning and the way we're using it? I think we can and should be thinking about computational methods as a quantitative method with a qualitative epistemology. I think we will be able to draw much more out of the method if we do that. And we can bolster kind of these paradigms like intersectionality and other cultural and inductive research to get this powerful new lens on thinking about things like inequality on an experiential level, on a cultural level, and not just on a like education, income, etc. level. And it's really not going in that direction, as in the world of computational methods and machine learning has not really gone in the direction. It's gone in the other direction of trying to bolster inferential statistics. This is a great paper. I love it. The title is really indicative of the way machine learning is often used. So the nearly universal link between the age of past knowledge and tomorrow's breakthroughs in science and technology, the hotspot. So this idea that we can be using these methods across a huge amount of data, many different contexts, and we can find these universal laws of society, almost physical laws of society. And that's what we should be using these methods for, is to look across all contexts and say, what is common across all contexts, and can we come up with these mathematical relationships between contexts? Another example is an early one by Michael Macy and Scott Golder. Diurnal and seasonal mood vary with work, sleep, and day length across diverse cultures. So looking at 4 different continents and showing that there's these kind of mood cycles across hours of the day. But again, it's indicative of this desire to get rid of context, to abstract out of context, and say, what are these universal patterns that we can draw using big data and machine learning methods? Just another brief example, Hot Streaks in Artistic, Cultural, and Scientific Careers, published in Nature. So this is the type of work that's being published in Science, Science Advances, Nature, thinking about these large data sets, completely getting rid of context and coming up with these universal patterns. Love this work. This work is great, but we can be thinking about these methods in a different way. Some of us can be thinking about these methods in a different way and applying them with a much different paradigm. And that would be or perhaps the future of machine learning is qualitative. Both machine learning and qualitative methods, and in particular intersectionality, the intersectionality paradigm, fulfill all of these things on the left. They're both of them, both machine learning and intersectional methods are relational, embedded, they're situational, they're contextual, they're constitutive, they're inductive, data-driven, uncertain, interpretive. So these descriptors suggest that the alignment between intersectionality and machine learning is very tight and can lead to a very productive research agenda. And I just want to emphasize this because I often get, unsupervised machine learning is inductive, but I'm making a strong claim here. Not just unsupervised machine learning, but supervised machine learning is a fundamentally mathematically inductive method. And that's really, really important here. So what does that mean when we're thinking about merging this new paradigm with the standard methods that we've long developed in the social sciences? Should we be better leveraging the alignment between machine learning and inferential statistics, which is what a lot of really smart people are doing right now? And I think it can be important work, but can we also do the other version? We can better leverage the alignment between machine learning and qualitative methods. And what would that look like? What are we studying and with what is? So this is what I think we should be thinking about as we go forward with these methods. What are we studying and with what data? A lot of these machine learning big data papers are on the Web of Science, Patents, IMDb, Yelp, Twitter, Reddit. A lot of these case studies are the population that we've always been studying. They're largely white, a lot of them are largely men, and that's kind of what we're replicating forward. So rather than calling in new populations with care, we don't want to surveil them, we don't want to be Big Brother, but calling in new populations with care that have been traditionally left out of the scientific record could allow us to do some much more interesting, powerful things going forward, rather than just replicating what we did previously. So we need to be aware of representation in our data. Who is in your data? Who is being represented? Who are you making claims about? It certainly is not everybody. Twitter is not everybody. So who is represented in your data? Context is critical. Rather than abstracting out of context, let's use the massive amounts of data we have to dig into contextual situations and think about how context is very important for different identities and institutions. We can make big data small again. So one of the problems with using big data and just using statistical averages or statistical aggregation on big data is you silence intersecting experiences. If you're looking for the dominant pattern in data and the dominant people in your data are white men, you're going to find patterns that are relevant to white men. We've had to do that in the past because of a lack of data. We don't have to do that anymore. We should never be silencing intersecting experiences through statistical aggregation. It's just not necessary. We can be digging into the different parts of our data and really thinking about how it's different across different populations. And we should approach it with a qualitative epistemology. It means reading your data, it means understanding your data, which may seem facile, but I think it's an important point to make. It means thinking about how qualitative researchers deal with case studies, non-random samples. Twitter is a case study, Reddit is a case study, IMDb is a case study. These are all case studies, and qualitative researchers, they're big case studies, but they're case studies. And qualitative researchers really understand how to use case studies to develop theory. So we can be drawing from that long methodological tradition and thinking about how we can truly build theory from these narrow, Reddit and Twitter are actually relatively narrow case studies, but they're important. And there's a whole bunch of qualitative lenses that we can be using to do that. So really just taking seriously that tradition to think about how we're applying it in the current day and age. I will stop there with the beautiful Emerald Elysium to remind us that not all categories are known, and we should be thinking about new categories in our data. And I will turn it over to Chris to guide the Q&A here. Thank you for having me.
Hey, thanks for a terrific talk. I think you're two questions in chat. The first one from Bill Roberts. Bill, do you want to ask your question.
Hi, yes. I'm kind of coming from a computer science background, and I guess I kind of think of word embeddings as primarily self-supervised or unsupervised.
Yes.
And so when you evaluate them in the CS context, typically, you have some extrinsic task. Maybe you're fitting a machine learning classifier.
Yep.
And so when you make decisions about smaller embeddings or longer embeddings, dimensionality, et cetera, you sort of make those such that you're optimizing whatever that other objective is. So here, these are sort of implementation decisions that you had to make. And I guess I'm just curious how your results vary based on these decisions.
Yeah, it's a perpetual problem, not just with word embeddings, but if you're doing topic models or classification is how you set your parameters, because they're hugely impactful on the downstream results. So I do sensitivity analysis where I vary things like the vector length. You can also have the window, right? Do you have a window of 5? Do you have a window of 10? Do you have a window of 20? There's a ton of parameters that you need to vary. And in this case, I don't have a ground truth. The point here is to inductively allow patterns to emerge from the data. So I don't want to have like, here's a truth that I'm trying to measure. I think that we as a community, as a social science community, should be working with perhaps computer scientists more to come up with a way to do these sensitivity checks when we don't have a ground truth. So I can imagine things like producing a heat map where you vary different parameters and see how robust or how consistent models are across these different parameters. I mean, there's so many you can vary. So I think one of the most important, and this is why I really appreciate this question, I think one of the most important things we can be doing as a kind of interpretive social computational social science, or whatever you want to call this, is coming up with a series of sensitivity checks that everybody should be going through when they're doing this type of work, both for the researchers and the reviewers who are reviewing the work, so we can be confident in the robustness of our results. So everyone that I've talked to kind of does it ad hoc. We all just do a few sensitivity analysis and see, does it really change the associations downstream, but it doesn't feel super systematic to me. And I wouldn't know what to ask other people, like, have you done X, Y, and Z sensitivity checks? And I would love to do this in a more systematic way. And I think there are some creative ways we can do it. And it's probably one of the most important things I think we need to do in order to really allow this method to kind of explode and be used in a rigorous way. So I would love to talk about ideas using, heat maps or anything like that could systematize the varying of the parameters when you don't have a ground truth that you're measuring it against. I love that question.
Okay. I think you have a question from Peter Blair.
Yeah.
Professor Wilson, thank you so much for a really terrific talk. I wanted to ask, how do you think about like who is the person that's writing the text, and how should we think about embedding that within the measurement itself? So it's, in part, it's a sensitivity analysis, but like we could even think about like if we were to bring that method into like today's context, where you have like different types of people like writing. Like I'm thinking about like Toni Morrison's like idea of like the white gaze. Like how should we think about that kind of conceptually and methodologically in this context?
So word embeddings, of course, do not consider the author anything about the document. It throws out all information about the document and just looks at the words. So if you're throwing in the sense of my corpus, which had a mix of author, gender, and races, it treated each word the same. So in my case, I threw out all that information. But if you have enough data, you absolutely could do things like training. In the word embedding case, you could train separate models for white authors, Black authors, white men, white women, as many as you want, as long as you have enough data to do it. So you could train the same word embedding model on different corpuses based on the author, gender, race, etc., and then compare those word embeddings. So the Kolakowski and James Evans article in American Sociological Review did this by decades. So they trained separate word embedding on each decade of Google books. So like 1900 to 1910, 1910 to 1920, and then they compared across and said, what is the association between class and, gosh, I don't remember what they were, like education and class across different decades. So I can imagine doing something very similar across different author groups. You need a lot of data to do it. So if you have enough data, you could absolutely do that. You could try to do things like word embedding alignments, which has been done in historical work, where you try to align the same embedding, but those are really, really tricky and quite, just frankly, they're just not great right now. So I would just compare and say, does the relationship between culture and race hold for when it's written by a white man versus a Black woman? And I think that would be a really fascinating analysis, and you could do it in a really systematic way. So that would absolutely be a fantastic extension of this. If you can get enough data, you need minimum 1 million words per corpus. So that's always the trick, but I love that.
I'm wondering if this kind of analysis is a substitute for actual reading and reflection and the generation of subjective experiences. And if that's the case, I don't know whether that's necessarily the case or a possible danger associated with it. That is, I mean, there's always been a tension between speed reading, as far as I'm concerned, and reading for comprehension.
Yeah. So, I mean, there's a couple, I'm just looking at the question you're writing just to make sure it sinks in. So there's a couple of different questions in there. One is, could you do this instead of reading? And for me, that answer is categorically no. You should be reading your text as well. And there's questions about whether you read it before or after, but I think you need to be understanding what's in your text, because as the question about the sensitivity analysis suggests, some of this stuff could just be an artifact of your algorithm or your parameter choices. So I think you need to be reading your text as a validity check, as a context, as just making sure this model is doing what you think it's doing. It's measuring what you think it's measuring. So in that sense, I don't think we can.
Given time constraints, you're likely to opt for speed reading.
Yes. Well, speed reading if you're trying to read a huge amount, but if you're doing targeted reading, which I think these methods, word embedding, but also topic modeling, can do a really good job at pointing you to specific documents that are representative of a pattern. And you can do a very deep, slow reading of 10 documents that are indicative of a pattern, and then 10 documents that are indicative of another pattern, and then perhaps 10 documents that don't fit any pattern. And that can be your really deep, slow reading. So it's a targeted deep reading, a targeted slow reading. So you're not trying to read 1,000 documents and get everything you can. In fact, that's exactly what these methods can replace, I think, is this idea that we can hold patterns in our head when we're speed reading across 1,000 documents. So it allows us to do deep, slow, careful reading because we're able to just read 10 documents and understand what those documents are representative of in the entire corpus. That's my preferred way of doing it. I'm all about slow, deep reading and thinking about it subjectively. I mean, this really fits well with like Donna Haraway's radical objectivity and thinking about this idea that different people will have different experiences. And when you aggregate across these experiences, that's when you start to approximate objective reality. And that's what these methods can do. Absolutely deep reading, absolutely slow reading. This can enable that, I think, in a really powerful way. Get rid of speed reading. Speed reading is useless.
David Lang, you have a question?
Yeah, I'm seeing this sort of bootstrap method used for generating these embeddings and generating standard errors. I particularly large corpora. I'm just sort of wondering, do you actually retrain the embeddings from scratch every single time?
Yep.
Okay, cool.
Yeah, so I did random sampling with replacement on the sentence level. So the number of sentences in the full corpus, I did a random sample with replacement 40 times to create 40 random corpuses, and retrained the entire word embedding model from scratch each 40 time. And then you just take the second to last and the second highest and second lowest for your 95% confidence interval. It's a huge amount. My corpus is really small compared to what a lot of people are working with. If you have a huge corpus, you could do it 20 times and get the 90% confidence interval. So that would cut it down by half. But it's a huge, huge amount of computational work if you're dealing with a large corpus to do that.
Okay. Out of curiosity, how long did this take you?
My corpus was 414 novels. It's really quite small. So it probably took a day and a half to do the confidence intervals. And it's not on a huge machine that I was working on. Ooh. It's kind of a standard computing cluster machine over a number of nodes. But yeah, it's on I know that Kolakowski and James Evans did it on Google Books, which is substantively bigger. That probably took them a full month to do it over 40 times. I think they did 20 actually. They did the 90% because it's such a large corpus. So they did it 20 times, not 40 times. Yeah, it's huge.
So I think we have a question from Anna Scarpellos.
Hi, thanks so much for a really beautiful talk. I had a question kind of coming at your project from a kind of political and epistemological standpoint. So speaking of this question of epistemology and the constitution of knowledge about the social world and what's at stake and who gets to analyze what and how, I was wondering what is at stake with your approach and how do you see it fitting into kind of sociology more general? Because contextual and relational analyses, for the most part, have often been relegated to the digital humanities. So it's, history, comparative literature, etc., which is devalued compared to more quantitative approaches. So I'm kind of wondering, where do you see the future of this for sociology, for qualitative approaches to ML within sociology?
I mean, I think it's a great question. Thank you, Anna, for that question. I think it's we're in a really, really interesting moment because a lot of people, a lot of quantitative scholars are kind of panicking a little bit. How do we incorporate these machine learning methods into causal analysis? So I think there's amazing work being done around causal analysis, but it's really been a struggle, like a big struggle with I brought up Matt Salganik, which is just a very obvious example of it, but it's like, the kind of trend these days is these models are not as good as logistic regression. So why use all of this computational power to do something that logistic regression does just as well and in many cases better? And so I think there's a moment now where people are holding conferences. There was a conference at Princeton that was like the future of machine learning for the social sciences. It is this moment where if we can enter that conversation and say, here's a future, and it's a really important future, and it's a rigorous scientific future, meaning we're taking very seriously the mathematical assumptions of machine learning. We're not trying to force like a feminist perspective or whatever on it. We're really taking careful stock of what machine learning actually does. It is very different than what logistic regression does. And I know computer scientists are going to raise their hand and say, isn't regression just machine learning? It's another form of machine learning. So we can talk about the difference between regression and machine learning. But it's a moment where there is a true, real struggle about how we integrate these methods into our standard kind of what we're doing. So this moment, more than anything else, is where we need to jump in and say, let's think about what qualitative methods offer us to make it more, just quite frankly, to make it more scientifically rigorous, really, truly, because we're matching it with the mathematical assumptions of these methods. I tend to be an optimist. I'm not super optimistic that the whole world, that this world is going to go qualitative and relational inductive, but I do hope it becomes a part of the conversation and is included in what this potential future looks like for computational methods, because I don't think it's a settled field. We're in one of the unsettled moments now. So this is the time where you can really change things and change paradigms. So it's an exciting moment and an important moment, I think.
I think we have time for one last question. Soon Young Park.
Hi, thanks for interesting talk. I was just like, I took like mixed method class last year, and I'm not expert. I'm not an expert in either machine learning or qualitative method, but my cursory observation there was that machine learning method probably can do a lot of things qualitative method are doing well, especially related to study more like exploring and discovering complexity in causal relationship, like things like sufficient and necessary conditions or active finality. So I was wondering whether, because you might have thought a lot about this problem, whether you think those connection is there or whether you have seen any paper that draws similar equivalence there.
Yeah, I mean, machine learning is often related to dimensional analyses, which is not the same as QCA, qualitative comparative analyses. I think I have not seen any papers that do that. So if anyone has seen any papers, you can plop that into the chat. I personally have not seen them. I think there is definitely potential there to see if there's any alignment between the kind of traditional QCA approach and these machine learning methods. And because some of them, in some sense, they're built on dimensionality reduction and dimensionality analyses, I think there could be a really great alignment there. I mean, it would take some thought for sure, and then thinking about how to pull that out. Working with the causal analysis people, the people who are trying to use machine learning to do causal analysis potentially could be really productive as well. So merging kind of three paradigms, the complexity studies, qualitative QCA, causal inference, and machine learning. Now there's an interesting mix of things that could go in a very interesting direction. It's a great question. Thank you.
Let's thank Laura for an absolutely terrific talk. Well, everybody's going to clap. I don't know if you probably can't hear them.
Yeah, I know, it's awkward.
But
Thank you
very
so
much.
Thanks, Chris and John, for having me here. It's been really fantastic. Thank you.
Okay. So goodbye, everybody.